Hey friends, Miss Willis here with your Honors Pre-Calc Unit 3, Day 4, Solving Rational Inequalities. Last video of this unit. I'll be back in 2 more units. It's been a pleasure. So this one's going to be short and sweet. 3 problems. Here we go. So we are solving rational inequalities. You did solving polynomial inequalities by looking at a graph and figuring out when it was above 0 and it was below 0. This one we're going to do a little differently because it's a little bit easier to do it on a number line. So I've already written down the problem. So make sure you write it down. First thing, so when you're doing these, you got to find 2 things. You have to find the zeros. And remember, that's the x-intercepts. And the way we find the x-intercepts when we talked about it in the graphing video is it's what's on top as long as it's not a whole. Okay? So right now it looks like 2x plus 1 is going to create my 0 unless that becomes a whole, which is highly doubtful since it has a leading coefficient of 2, but that's where it's coming from. All right? So then the other thing you have to do is find the undefined values. Now remember, that is my wholes and vertical asymptotes. All right, so we need to find all of those as well. So how do we find them? We need to factor our rational equation. So the top doesn't factor, so it stays 2x plus 1. There's no GCF, there's no anything. The bottom does factor. So I get x plus 3 and x minus 1. So I don't have a whole, so I'm going to go ahead and say no wholes. Okay, so my 0 comes from the top, so I set that equal. 2x plus 1 equals 0, and then I solve. So I get 2x equals negative 1. When I divide, I get negative 1/2. So my x-intercept is negative 1/2, comma 0. All right. So now I need to find my vertical asymptotes. So the vertical asymptotes come from the bottom, and that's going to be x equals negative 3 and x equals 1. All right, these are important because this is going to help me determine if I'm going to use brackets, parentheses, when I write my interval notation. And these are like the points where things kind of start changing. So looking at this, it wants to know when is it less than or equal to 0. So it wants to know when is this graph below 0? When is it negative? Okay, so with the equals to signs, I'm going to end up using brackets for my zeros if they are a part of my solution because it wants the equals to part. Okay, well, I mean, that 0 is going to be a part of my solution no matter what. If it's not in that interval, then I just put it as a single number with brackets because it's wanting it equal to. Okay, if it's undefined, I'm always going to use parentheses. I'm going to put it in parentheses. Okay, I'm going to use parentheses every single time. I don't care if it's less than or equal to, greater than or equal to, less than, greater than, I'm going to use parentheses. Now, if it was less than or greater than with no equals to, my zeros would have parentheses. Okay, so let's make a number line. We want to put these values in order. So the lowest number I have is negative 3. Then I have negative 1/2. And then I have 1. All right, so this is about mental math. I got to figure out if I plug in a value into these equations between all of these intervals, what kind of sign am I going to have? Am I going to be a positive value or am I going to be a negative value? So something that is below negative 3, I'm going to plug in negative 4. Could I have plugged in something else? Yes, you could have plugged in negative 5, negative 6, negative 7, so on. We're getting closer to negative infinity. You don't want to plug in something ridiculous because you do got to be able to do the mental math. Okay? So if I plug in negative 4, I get negative 8 plus 1 on the top. So I'm plugging it into the top first. I get negative 8 plus 1, so that makes a negative. On the bottom, I like to plug it into the factored form. It doesn't matter. On the bottom, I get negative 4 down here. Well, negative plus a smaller number is still going to be negative. Okay, and then I have negative 4 minus 1. Well, negative 4, take away another 1, guess what? That's still negative. All right, so on the top it doesn't change, but on the bottom, a negative times a negative creates a positive. So what is a negative divided by a positive, y'all? Oh, you're right. It is a negative. So this whole section is negative. So we actually want that section. So that's going to be part of my interval. So the first part of my interval, which I don't usually do this, but I'm going to, is negative infinity to negative 3. And I'm going to remind myself, this one was undefined, this was a 0, and this one was undefined, because that's going to be a parentheses for an undefined value. All right? All right. Let's plug in the next one. So what's between negative 3 and negative 1/2? Negative 1. Okay? So if I plug in negative 1, that's negative 2 plus 1, negative on the top. If I plug in negative 1 into that bottom parentheses, 3 is bigger, so it's positive. Negative 1 take away another negative is still negative. So I have a negative divided by a negative, which makes a positive. So I'm not going to use that section. That's not part of my solution set because I only want negative values. Okay, so let's check the next one. Ooh, this one has the good number to plug in, 0. 0 is nice because it takes away your x. So on the top, I get positive 1. On the bottom, I get positive 3 and negative 1. So a positive divided by a negative creates a negative. So I am going to use that section. There's another one. So I'm going to union this guy. I already did. Okay, so that 0 gets a bracket, and it's negative 1/2 to 1. 1 gets a parentheses because it's undefined. You're going to get graded on brackets, parentheses, all that fun stuff. All right, last one, last little section. I'm going to plug in 2. 2 times 2 is 4 plus 1, that's positive. 2 plus 3, that's positive. There isn't any negatives involved. 2 minus 1 is also positive. That is just straight positive, so we should know that. It's a positive. So my final answer is this guy right here. It's a lot of thinking. You got to be able to do the mental math. You got to be able to think, what are we going to get when we do this? All right? All right. Here's your next example, friends. So write it down, please. All right, so this one becomes a little bit trickier. So it is not equal to 0. And that is kind of okay, kind of not okay. All right, so you don't want to start by factoring this guy straight off the gate because that 5 is going to end up causing that value on top to change. So right now it looks like it could be a whole, but it's not because of that 5 over there. You really do want it to be equal to 0 when you're looking at wholes, but for these problems in our class, it's not necessary. We're not going to give you a whole for this guy. So here is what we need to find. We need to find our zeros, and we need to find our undefined values. So we need to find the undefined values first before we start solving for the zeros. Okay, so undefined value is x equals negative 8. Now, the way we find a 0 when it's not equal to 0 is we got to solve it like we just solved rational equations. So I'm going to make it an equal sign right now because we're trying to find which value of x is the solution to this. That's a 0. The value of x that is the solution to this is my 0. Okay, so I can't just look at the top for this because it's not equal to 0. So be careful with these types of problems, okay? So to solve this, my LCD is just x plus 8. So times x plus 8 times x plus 8, okay? That cancels, and I'm left with negative 2x minus 19 equals negative 5 times x plus 8. Okay, now I just solve for x. Negative 2x minus 19 equals negative 5x plus a, whoop, nope, gotta distribute. Be careful, it's not plus. So negative 40. I add over my x, I get 3x. I add over my 19, I get negative 21. So x equals negative 7. So my 0 is negative 7. Easy. Okay. The other way to do it is to get it into a simplified form, but that takes a lot more work because you have to add over the 5, get a common denominator, make it one single fraction, and then you can find your 0 that way. Okay? So this is a lot easier. So we're going to make our number line. So is anybody going to have a bracket in this problem? I don't know. Do you know? Okay, well, looking at this symbol, it's wanting it to be greater than. That symbol is not going to change even when I move over the 5. So it's wanting the positive values because it's going to be greater than 0. Okay, so we want the positive values, and it's no brackets because it's just greater than, not greater than or equal to. So my number line is negative 8 and negative 7. Okay, and we're going to plug in our values. So on the first section, so remember we're going from negative infinity to infinity. So on the first section, I'm going to plug in negative 9. Okay. I'm going to move over the 5 to make this easier. Negative 2x plus 19 over x plus 8 plus 5 is greater than 0. Okay, if I plug in negative 9, this one you're probably going to have to figure out your actual values, not just the signs. So if I plug in negative 9, what do I get? I get negative 18 plus 19, so I get 1 over negative 1 plus 5. So negative 1 plus 5 is positive. This section is positive. Okay? Next number I'm going to plug in is, negative 7.5. Okay, so what am I going to get? I'm going to use a calculator because this is decimals. I know that I get a positive on top, and I just want to use a calculator. Negative 7.5 times 2, I get it, yeah, negative 15 plus 19. Negative 15 plus 19 divided by negative 7.5 plus 8, which is 1/2. So negative 15 plus 19 divided by 1/2 is 8 plus 5. So that's positive. I messed up somewhere. Oh, that's supposed to be minus 19 up on the top. I'm not redoing this video. Bump that, y'all. Bump that. Okay, so that's still negative 15 minus 19. So that's going to be a little bit different. Negative 15 minus 19 is negative 34 divided by 0.5 is negative 68. So this is a negative. All right, okay. So did that affect though? Let me see. Negative 2 times negative 9 minus 19 is negative 1, which was positive 1. So it didn't change that first section. All right, we're good to go. Good to go. All right, and then I'm going to pick 0 for this last number. Anytime I can pick 0, I'm going to pick 0. So I get negative 19 divided by 8, which is negative 2.375. If I add 5, that is going to be a positive number. All right, So my section that is greater than -5, positive, is from here to here, okay? Greater than 0 when I move over that 5. All right, so it is from -infinity to -8, union -7 to infinity. All right, that was fun. I mean, I clearly used a calculator for this, so I probably would let you guys use the calculator for a problem like that. All right, you just got to be able to show your work, though. All right, so here is number 3. Number 3. This one's way easier. See if you can pause the video and do this problem for me. See if you can do it. All right, so on the top, I can factor that to x minus 7 and x plus 4. On the bottom, I can factor that to x plus 1 and x plus 5, greater than or equal to 0. All right, so nothing canceled. So let's find everything. My zeros are x equals 7 and x equals -4. My undefined values are x equals -1 and x equals -5. And now I'm going to make my number line, my sign chart, as some people call it. So I'm going to label it. It's -5, and that's undefined because we got to worry about brackets in this one. The zeros are going to have brackets. Zeros are going to have brackets because it's greater than or equal to. All right. And then I'm going to put -4. That's my 0. And then I'm going to put -1. That's undefined. And then I'm going to put 7. And that is my 0. All right. So using our brain, let's pick a number. This is probably the most draining part, is using our brain. So I'm going to put a number. I'm going to pick -6. That first parenthesis is definitely going to give me a negative, because if I keep subtracting from a negative, it's still going to stay negative. -6 is bigger than 4, so that's a negative. -6 is bigger than 1, so that's a negative. And -6 is bigger than 5. So that's a positive divided by a positive, which is positively beautiful. All right, so I like doing it. This one's not as bad, so -4.5. Who's bigger? Well, if I keep taking away a negative, that's negative. Who's bigger, 4.5 or 4? 4.5 is, so that's negative. 4.5 is bigger than 1, so that's a negative. But 4.5 is not bigger than 5, so 5 overtakes, and that's a positive. A positive divided by a negative is a negative. All right, and then I'm going to plug in -2. I get negative on top because I'm still taking away. 4 is bigger, so I get positive. 1 is not bigger. -2 is bigger, so negative wins. And 5 is bigger, so positive wins. So that's a negative divided by a negative, which makes a positive. All right, 0. 0 gives me a negative on top because it's just 7, and then +4, and then +1, and +5. So negative divided by a positive equals a negative. All right, last one, 8. So if I plug in 8, I get positive, positive, positive on there, and positive, because 8's bigger than 7. That's the only one that would have made it negative, is that subtracting. Okay, so that makes a straight positive. All right, greater than or equal to. That means I want all the positive values. So this section is positive, and this section, and that's going to infinity. So if we wrote this, it would be -infinity to -5. Now, do I use brackets or parentheses, y'all? Parentheses is correct because it's undefined. Okay, from -4, though, I'm going to use a bracket because that's a 0. -1 is an undefined value, so that's parentheses. Union, I'm going to use a bracket for 7 because it's 0 and go to infinity. Woo woo! Not so bad. All right, that's it. It's been real, y'all. See you in 2 units, so unit 6, because I'm not doing 4 or 5, so unit 6. Bye!